The 360 on Energy and Carbon, hosted by 360 Energy. On today's episode, we are joined by Bruno Miller from Air Company. Mr. Miller is Vice President of Commercial Development and Government Affairs at Air Company, a leader in the conversion of carbon dioxide to products including sustainable aviation fuels, SAF, and industrial chemicals. Bruno Miller is a recognized expert in the SAF industry with over 20 years of experience working at the intersection of technology, commercialization, and policy to make commercial availability of low-carbon fuels a reality. Now let's get into the episode with Bruno. Welcome back, Dave and John.
Great to be back.
With Sandra, John, it is great to be back. And something I don't think you've ever known about me is aviation is one of my favorite topics, and I researched. So our guest today is really timely to talk about this. So I'm looking forward to it.
On that note, today we're joined by Bruno Miller, Vice President of Commercial Development and Government Affairs at Air Company. Welcome, Bruno.
I'm happy to be here.
Bruno, can you tell us a little bit about Air Company and who you are?
Yes, Air Company is a technology development company that was founded in 2017 with headquarters in New York City. We are at the core deep decarbonization company, looking at taking the best out of synthetic chemistry to reduce carbon emissions in hard-to-abate sectors like aviation, industrial processes, and heavy-duty transportation.
Now, I'm also really excited about this conversation because I am an avid traveler and I would like to continue traveling, and hopefully as it becomes more sustainable, we can do that. So with that, what is the current carbon footprint of the aviation industry and why is it so crucial to find sustainable alternatives?
That's a great question, and happy to shed some light on it. So current estimates are that the aviation is responsible for about 2 to 3% of global climate emissions of CO2. And why that? And so that's a big number, right? 2 to 3%, imagine, of all of the activity on the Earth. But what's even more concerning, or what creates a lot more urgency, is that as other sectors in the industry decarbonize, the relative share of aviation is going to grow. Right. And so there are projections that this can double to, anywhere to 5 or 6%, or maybe even higher. So that's why, even though the problem is already urgent today, it's only going to become even more urgent as time goes on and the industry grows.
Thank you for that. I think that puts it in a good context. So we're going to get specific about why you're here. How does the Air Company's air-made system differ from traditional approaches to carbon capture and utilization, and CCUS for listeners who want to get the full experience? So how is it different?
Yeah, that's a great question. So at the core, Air Company is a technology development company. So we have lots of scientists and engineers that are tinkering in the lab every day, looking for very specific technology to take CO2 and hydrogen and turn that into useful products. Now, there are multiple ways of doing that out there in the industry. And what we have done is to do this in one single step, where you take your CO2, hydrogen, and then you have direct conversion into alcohols or hydrocarbons. This is different from other approaches where you first, you take your CO2 and hydrogen, go to something called a synthesis gas, a syngas, which is a very well-known substance in the chemical world. And out of syngas, you can make so many products. But in order to get to fuels, you need to go through a second or third reaction called a Fischer-Tropsch reaction. And that adds complexity, adds cost, and adds more effort to the whole endeavor. So Air Company was really founded on this idea that you can go directly from CO2 and hydrogen to hydrocarbons. And that's what we bring to the industry.
Okay, can I have a follow-up on that, which is, where does your CO2 and hydrogen come from? How are you sourcing that?
Yeah, great questions again. So we are very agnostic to where that CO2 and hydrogen come from. They need to be relatively clean, but it's nothing that it would be out of the ordinary from industrial source CO2 or hydrogen. Now, when we're talking about really decarbonizing aviation or other industries, right? Because our platform can also be used for renewable chemicals, renewable alcohols like methanol, and also going to renewable diesel, sustainable aviation fuel. But those are only beneficial in terms of carbon reduction when two things happen. First, our source of CO2 is biogenic, and there are many sources of waste biogenic CO2 out there that we're targeting. We can also look into waste industrial gases that, depending on how you do your life cycle analysis, are also very beneficial in terms of reducing emissions. So that's what we are looking for. And for our first application, we're looking at waste biogenic CO2, which provides one of the strongest CO2 reductions. Now, the other big component is hydrogen. And how you make the hydrogen is very critical here. So we're looking at renewable or green hydrogen made from renewable electricity. And that's important, right? Because today you can make hydrogen out of natural gas. That's referred to as gray hydrogen. That doesn't do you many good in terms of CO2 emissions reduction. So we are very purposefully looking at the green hydrogen to achieve the deep CO2 reductions that we need.
That's great. Could you, for clarity for us all, explain biogenic CO2?
Yes, that's it. Biogenic means that it's a source from living organisms.
Right.
So this is not the fossil-based substances or materials.
Thank you.
Bruno, I'm so glad you're here. And because there is, as we've explained, a lot of interest in the aviation industry, not only by us, but our listeners. Can you share some of the economic models or case studies that demonstrate the viability of low carbon fuels in aviation?
Yes, that's a very good question. And let me put a little bit of context into that, because I've seen my share of sustainable aviation fuels over the years. So I started my career as a fuel buyer with Northwest and Delta Airlines over 10 years ago. And the interest of the airlines started a number of reasons, obviously environmental responsibility, but also in the 2008-2009 time period, you may remember that the price of oil just shot up to $140 per barrel. And that created an existential threat to the airline industry because you just could not cover the cost of fuel for certain flights. And that was a big wake-up call for the industry in terms of what do we do in a high oil price environment. And so the industry is starting to look for alternative fuels to fossil fuel. Now, what we're talking about here is starting a whole new industry, right? And that's always difficult in the best of times, but also really hard when you are trying to replace a product that has been made for 100 years, right? There is a big industrial base. They have their economics pat down. They have the investments. They have the resources to continue producing it. So what do you do? Well, you try to look for the lower cost approaches to making this. And when you look at the sustainable aviation fuels or renewable fuels in general, the feedstock is a key component of that cost structure, right? So you want to look for the cheapest source of feedstock of raw material that you can. You may be aware, and the listeners might be aware that today one of the most prevalent sustainable aviation fuel is what we call HEFA, hydrotreated esters and fatty acids. Is made from bits, vegetable oils, animal fats, used cooking oil. So the industry really got started looking at the waste materials, especially used cooking oil and tallow, which is a rendered fat that are discarded, that are waste. Why? Because again, it's a really low cost of feedstock. And the technology to turn those materials into fuels, renewable diesel or sustainable aviation fuel is fairly well understood. To some extent, is a process that is used in refineries today. So the technology risk was not that difficult. And There was a company in California that started this process, was the first one to produce sustainable aviation fuel on a regular basis. And it's still there today, and it's one of the flagships of the industry. It's now run by World Energy. And so that technology is today the most prevalent one, and it works economically. Now, a waste is only a waste when nobody wants to use it, right? But as there is more interest, and that waste becomes valuable. So sources of inexpensive fat and oil are diminishing, right? Now, used cooking oil used to be discarded. Now you have to go pay a little bit for it, and same is going to happen with animal fat. And so HEFA has done a great step forward for the industry today. And having said all that, HEFA is still more expensive than Jet A. There is a premium. That is compensated in part because of the environmental benefits it brings, right? On a lifecycle basis, it reduces carbon emissions. And airlines and other actors are willing to pay for it. When I say other actors, right now we see a lot of interest from corporations. For example, Microsoft or big consulting firms that fly a lot, and they want to decarbonize supply chains. They want to decarbonize their employee travel. So they're willing to voluntarily pay a little bit extra to have those, that sustainable aviation fuel be credited to their travel. So the industry is finding ways to close that price gap. Now, fast forward, so we're talking about 100 billion gallons. That's more or less what the aviation industry burns on a global basis today. And we probably have 100 million gallons of SAF available today. So that's very small amounts, right? So we need to grow to, stop talking about millions of gallons and go to billions of gallons. But as we do that, again, the cost is going to be a key barrier, and we need to look for cheap sources of raw material to do this. So in addition to the oils, fats, and tallow that we just mentioned, another technology that is out there is the so-called alcohols to jet. This is where you take things like methanol or ethanol, and then again, a chemical process, and you turn it into sustainable aviation fuel. Another technology that is not quite as widespread as HEFA, but it's coming. It has a very good chance of, having a significant volume. But there you are competing a little bit against the existing ethanol markets, right? Ethanol is a product that is traded today, and people find value. So again, the opportunity is how can you source low-cost ethanol, and also low-cost ethanol that is very low carbon. There are other materials, municipal solid waste, the woody biomass, that are low cost in principle, but it's the logistics that get tricky. Woody biomass, if you can harvest it from the forest floor, is relatively inexpensive, but you can only gather so much, right? So at some point, how much you have to travel with your trucks to go collect that, the fluffy material starts to happen on it. Now, air company, right? And the so-called e-fuels and power to liquids. Why do I have so much interest, and why do I join this company? It's because I see a lot of potential for sourcing low-cost waste materials for making fuel, right? So we mentioned biogenic CO2. There are different sources of this material out there that can be low cost. And so we're looking into that. And arguably we have too much CO2, right? It's a problem. So how can we then take that excess CO2 and then turn it into something useful instead of having to drill it out of the ground? And I think to the extent that we can continue developing technologies like ours, and there are other e-fuel or, so-called power to liquids companies out there, and we all have our preferred machine. And I think there is room for all of us in this context, right? Where again, it's 100 billion gallons. That's a lot of fuel. And to the extent that we keep developing these technologies, I think cost is going to come. So the other element that we mentioned is hydrogen, right? And so we at Air Company, we're focused on doing the CO2 and hydrogen conversion to hydrocarbon. We need somebody to really work on the hydrogen side and look to be able to make hydrogen, green hydrogen, at a low cost. In the United States, for example, the Department of Energy has a big program to do just that with the so-called hydrogen hubs. And we're really, rooting for them to bring down the cost of hydrogen. Now, they're not doing it only for us, of course. I mean, hydrogen is a very used commodity in industrial processes and many other processes. And then there are plans to decarbonize industries by using green hydrogen instead of fossil fuels. So green hydrogen has a big feature. So we are very encouraged by some of the progress. We need to do more. Certainly the e-fuels, the power to liquid, we have, I would say, a midterm time horizon, right? 4 or 5 years before we start seeing large production of our product. And that all comes back to your question about the cost, right? So we need to do this step by step, but I think we are on the right track to do that.
Thank you. It gave a lot of detail on what the industry is all about and the challenges and some of the things that are going on. So thank you for that information. I do have a quick follow-up because prior to recording this, we talked about you have some work that you're doing in the Niagara area. I am well aware, and I'm kind of curious, hydrogen with OPG is doing some work on hydrogen in Niagara Falls area. I'm curious because I know hydrogen is big everywhere. Everyone's trying to focus on that. Is your sources of hydrogen, are you looking at typically being localized in certain areas, or where are you looking to get your hydrogen from, per se, for this project to be effective?
Yeah, in terms of the sources for hydrogen, again, we are, to be honest, we're looking for the lowest cost green hydrogen that we can. Now, in the upstate New York area, Niagara Falls area, there's a lot of hydroelectric power, right? So any hydrogen that comes out of hydroelectric electricity is a good source of hydrogen for us. It's not the only one, right? So there are wind projects or solar projects. I guess the upstate New York area is not well known for solar resources, right? You see more of that in the southwest of the United States. But again, we are not picky as long as we can get the low cost, the green hydrogen that we need. And again, we look to partner with others to source the hydrogen. We'll go do it ourselves if we have to, but if we can work with others, that's what they do, right? It is their business to make green hydrogen. Then we're more than happy to partner.
Fair enough. Thank you.
This is getting quite interesting, isn't it? Because we've got so many different threads that need to be put together. I want to talk to you about technical challenges in both producing and deploying low carbon fuels on a large scale in aviation. And I think a question we haven't touched, for example, is, do we have to change jet engines? What technical things are going to be required, if you like, in the whole flow cycle of fuels to airlines? Will there have to be different ways of storing fuels, etc.? Could you explain something about that?
Yes, definitely. So one big assumption or foundational principle of aviation is safety. The entire industry is based on being safe, right? You get on the airplane, you fly, and you get to your destination, and everything is safe, right? And you may get your bags, which is always great. Then you may get there on time, which is even better, right? But as long as you get there, that's the main point. So now comes fuel, right? So fuel is a critical part of the entire mission, right? And it's not only critical for safety, but it's also critical for cost. And so from the very beginning, when we started looking at alternative fuels for aviation, one premise was not negotiable. The fuel had to be safe, and the fuel had to work with the existing equipment and infrastructure. Because if we were going to introduce a new fuel, that would be a lot of cost and a lot of changes to an industry that it's already built a lot of infrastructure. And it's not that it's not possible. It would just take so long that, the chances will be very minimal. So from the beginning, then this concept of drop-in fuel has been around. And there is an association called ASTM International that creates standards. And you see it sometimes on crayons or toys or pools, right? ASTM is it. So there is an ASTM standard for jet fuel. And traditionally, the ASTM standard was only for fossil-derived jet fuel, Jet A and Jet A1. Now, when alternative fuels started to come around, there had to be some changes to the ASTM specification, and they were made. And now we have about 8 pathways that are approved that use not fossil raw materials, but as we mentioned, the vegetable oils, the alcohols, and other materials. Now, one big consideration here is that for the most part, the sustainable aviation fuels that have been approved today, they have to be blended with fossil jet fuel, because there are certain components, broadly speaking, called aromatics, that processes like the HEFA, like the hydrotreated oils, vegetable oils and tallows, that process does not produce aromatics. Some of the alcohol to jet pathways also do not produce aromatics, and a few of the others don't make aromatics. But conventional jet fuel has enough aromatics, so if you blend it up to 50%, then by and large you should be fine. There are a few other tests that you have to do on density and a few other things just to make sure you meet the spec. But by and large, so there is a blending requirement. Now at Air Company, to come back to what we're doing, we have in our process we can make those aromatics as well. So we can produce a fully formulated fuel. And so we're taking it a step forward, right, from the existing fuels in use today, where we will be bypassing the need for blending potentially, right? So we're going to be making a fully formulated fuel that then, John, to your point, can go straight into the wing of the aircraft and then into the fueling depots at the airports. And that's the ideal. Now, between now and then, there's still work to do. That's for sure. But that's where we're aiming with the process at Air Company.
Thank you. That's interesting. Yeah. Bruno, can you explain the life cycle of the Air Company's fuel from CO2 capture for its use in the aircraft?
So the life cycle carbon accounting is very important to this. So let me try to put it in simple terms, which is not always easy. So as I mentioned, so we are focusing on biogenic CO2. So this is CO2 that would have otherwise been released into the atmosphere. So we are capturing it before it goes into the atmosphere. So we have a credit, right? Now we have a CO2 that we have, it's in our bag. And then we take green hydrogen that is also low carbon or ideally zero carbon. So we have now a carbon credit in our bag, right? We're going to go through some processing. We need a little bit of energy for, just the chemical process. Our process also releases some energy, so we get some of that. Now, at the end product, if we're looking at renewable diesel or sustainable aviation fuel, is going to look like a hydrocarbon, right? It is a hydrocarbon. So when you burn the hydrocarbon, you're going to be releasing the CO2 back into the atmosphere, right? But again, because we have this waste biogenic CO2 that we have in our credit bank, when we release it, right? So we're just compensating for the CO2 that we took in the first place. So the net result is that our carbon footprint is very, very, very small. Like we can achieve upwards of 95% carbon emissions reductions compared to conventional Jet A by doing this process.
Wow, 95%. Oh my gosh. Yeah, that's fantastic.
I'm so glad you explained that, because I was sitting here listening to this and think somebody's going to go, hold on a minute, you're making a hydrocarbon and you're claiming it's low carbon. I think that was a really good explanation, because it's the biogenic CO2. It's not new CO2 that's being introduced, is it? Yeah.
Exactly right. Yes, and if I may, because we're focusing on carbon, but there are other attributes of this fuel that make it better than conventional jet fuel, and it doesn't have as many contaminants,
right.
particular sulfur and particles that create soot, right, and contribute to smog. And again, it's not only the air-made process, but also the other pathways that I have mentioned, because it's just the raw material, right, the fossil crude that you dig out of the ground comes with a lot of metals and minerals and other things that just end up in the final fuel. Because of these sustainable fuels are essentially manufactured from cleaner raw materials, you don't end up with so much contaminant.
Bruno, I'm so glad you brought that to our listeners' attention, because so often when people are looking at this new transition, they don't realize the other benefits besides the economic benefits associated with it. And you just made a very clear case study of the other benefits that are achieved from this process. Thank you.
Okay, can I take us back to economics? And I'm interested in what the economic benefits for airlines and passengers will be. And I'm guessing it's in the future if the industry transitions to low carbon fuels. And if I can add to that, I thought it was really interesting, your point that the key thing for airlines is safety. And I know we have a budget airline in this country called Ryanair, and their whole point is the biggest failure they could have in public relations would be something related to safety. Anything else they don't mind if they've got problems, they can make positive PR of it, but safety matters. And I think to me as a passenger, well, all of us as passengers, we want it safe. Let's hope our bags arrive. Let's hope it's on time. And we also want it low cost. So we're all, at the end of the day, with a lot of these things, driven by economics. So I'm going to partly answer your question, and you tell me if I'm wrong. We hope if it's got economic benefits for the airline that they will share those benefits with us. But is that going to be the case? What's going to happen in the longer term to the economic? Will there be economic benefits of having a sustainable fuel?
That's such a great question, John. And we'll probably need like 2 more podcasts to really go into all the details. Because let's try this for starters. So why do people fly, right? So few people that are really like flying, right? And just cherish being there on an airplane. But for the most part, people fly because they want to go somewhere either for business, for vacation, for visiting friends and relatives, right? There's something you want to do. And then when you look at the economic benefits of the aviation industry, right, they're vast. So there's a lot of economic growth and economic activity that is facilitated by aviation. Now, there's a lot of concern, especially in Europe, and it was mentioned here earlier, right, about me as a flyer, what is my carbon footprint, and is that responsible, and right? So there is a concern. And this concern also has, to be very honest, has been enshrined in regulations, right? The EU emissions trading scheme, including aviation, right? That was another big wake-up call for the aviation industry. It's like, well, regulators are serious because society wants to do something about it. So another big reason for sustainable aviation fuels from the airline perspective was to get the so-called license to grow. Right. So we want to grow this industry and we want to do it environmentally responsible. And so we're going to be doing a number of things, including sustainable aviation fuel. So in that sense, so that's one way to answer your question is if we value as a society flying, the benefits come from flying, and we want to continue reaping those economic benefits, then we need to be accountable for our CO2 emissions. Sustainable aviation fuel is a way to get. It's not the only one. There are other opportunities, but by and large, sustainable aviation fuels is going to be an important way to do it. And you can say, that's great, Bruno, society, but what about the individual consumer, right? What about I'm trying to go from A to B. I don't have limited resources. Can sustainable aviation fuel help here? And to answer that, it's I don't know yet. I hope so. And the reason is because we are creating diversity in the fuel pool. And the more options you have, then that tends to benefit the consumer.
More competitive it gets.
Right. Now, there's also, and this is super interesting, and it's something that I've been convinced that the solution is somewhere in there. When we do not look at the traditional oil and gas industry as the adversary, but also as a collaborator, as a partner. They have the infrastructure today, right? They have the refineries, they have the plants, the trucks, barges, all of them. And they are trying to also diversify their crude oil. And there are ways to create these synthetic hydrocarbons so that they can go into refineries. So there is a concept of co-processing. This is where you take so in this context is when you take a biomaterial, like animal fat, for example, and you put it into a standard refinery alongside petroleum, and then you can co-process them. And then out comes a fuel that is partly fossil and partly bio. And so that technology exists today. There are at least two pathways that can do it. And it's something that I think has a lot of promise, again, because going back to what we mentioned before, we're trying to stand up an industry. And wouldn't it be just better if we find ways to work with what's already out?
Interesting.
My sense, Bruno, as you conveyed, is, and I understand this is fairly new, so it's a pretty immature sector or technology currently, but as it matures, economies of scale will occur and then pricing will get competitive. And as you've already suggested, you've got competition right away that kind of forces you to be as low as possible based on, like, it will be a natural cause that will drive, the market will drive the cost accordingly, what customers will pay.
Yeah, no doubt about it, right? The economies of scale can be there as we scale up, or that's what we're counting on, that will be there. Another benefit, again, maybe a little bit more from a macro perspective, is a distributed production, right? Right now, oil production, we know where the oil is, and that's where we're drilling, and that's where, where a lot of wealth is amassed. But what about other parts of the world that are rich in other resources like solar resource or wind resource, right? So processes like ours, where what you need is CO2 and a lot of electricity to make hydrogen, right? So this can also bring benefits to other parts of the world and try to, create other industries, other economic opportunities. And not only our process, but, when you look at the different pathways for sustainable aviation fuel, which I think, in the long run can also be part of the solution for reducing costs, right? To the extent that we can reduce the cost of one of the main inputs into flying. No doubt there's always going to be a market and market pressures. There's going to be a balance there. But again, if we can create more sources, more, diversify and have more, and at least cut down on the cost of transportation, I think that can all benefit.
Thanks for a great episode, Bruno. To end off this episode, what is the biggest takeaway for our listeners?
Yes, one takeaway I would like people to take is that the sustainable aviation fuels have made a lot of progress in a very short period of time. Now we have facilities that are producing SAF on a regular basis today. We still have more to go, but I'm very optimistic about the future. I think the technology that the air company is developing is going to be part of that solution. It's not going to be the only one. We need many of us to make a big dent. And I think that the opportunity is there. And I'd like to thank you and, and your listeners for helping to disseminate the message, and happy to answer any questions.
Thanks, Bruno. Dave, what's your biggest takeaway?
Fascinating topic. One of the things that Bruno mentioned is that the regulatory system seems to be more advanced, and they've noted already different ways of using CO2 pathways of how to produce and process fuels. And so it seems to me that has actually helped advance this process. And why I'm bringing that up is that we see in so many industries that the regulations are way behind, and it doesn't advance people. So it sounds to me that, I know you conveyed you were in Washington. I don't know if that's a big part of your job, is to convey to the government and the different regulatory bodies that this can and should be done. It sounds to me that has really helped your cause to advance that. That's one of the big takeaways I've had.
Dave. John, what's your biggest takeaway?
My biggest takeaway is that I'm quite a committed environmentalist, and I always feel guilt when I'm flying, and I try to minimize it. I do a lot of my travel by train where possible, and as you probably may be aware, France and a couple of other jurisdictions are trying to ban domestic flights if there's an equivalent rail service available. But I like travelling, and I like the idea that sustainable aviation fuel may take away my guilt in flying, and that would be wonderful.
Agreed on that, John. Well, Dave, John, Bruno, thank you so much for a great episode.
Yeah, really interesting. Thank you.
Thank you, Bruno.
Yeah, thank you.
That's all for today's episode of the 360 on Energy and Carbon podcast. Thanks for listening. Make sure to check us out on our website at 360energy.net and follow us on LinkedIn at 360 Energy Inc. Tune in to our podcast on Apple Music, Spotify, Anchor, or other listening platforms by searching the 360 on Energy and Carbon. You can watch the video recording and subscribe on YouTube at 360 Energy Inc. Email us your feedback at podcast@360energy.net or comment on our LinkedIn posts. See you next week.